Assalamu alaikum guys, my name is Abu Bakr and I'm here to teach you C++ programming. We're just there now. It's coming to an end. The journey that we started the last month is coming to an end now. So does this course. Now, in today's class, we are going to learn about the fourth relationship between the classes, that is in the different category, that is a parent-child relationship in the class. So this one is called inheritance. You probably heard about it, and this one is really useful when you want to do, polymorphism. Now, what we have in this kind of relation, it's more like going from generic to specific. If I were to create a class of vehicle, and then I were to create a class car, then I were to create a class, say, Ferrari or Lamborghini. So it's more likely Lamborghini is a car and the car is a vehicle. So these can be parent-child relationships. Now we need to think of all the, just like last time when I started teaching you classes and structures, I told you whenever you are trying to create a class, leave your trackpad and mouse and keyboard aside for a minute and think what a vehicle generally can have. So a vehicle can have its engine, it's a string, std string. It can have its engine. Okay, I'm not going to create a std string make here because make is already done, it's Lamborghini. Okay, so I'm not going to do like, but I can have a what do you say, color, because every car has a color. So std string color. Okay, then we have car coming up, but before we do, we need to understand one thing. Car is actually a vehicle that has engine and it has a color. What are the additional things it has? We're going to think about that after a minute. But first, we need to understand the car is actually the child class of the parent class vehicle. So what we need to do, car is going to inherit things from vehicle. So when I put colon, I'm going to write vehicle class. So now car class inherit things from vehicle class. That means all these properties have already inherited by the car class now. Now, what a car class can have further more than the vehicle? It can have its what do you say, seating capacity. So int seating capacity. Then you can have I cannot come up with anything more. It's type, either it's hatchback or sedan. So std string type, whether it's a hatchback or a sedan or a sports one, anything like so. And now we need to know that a Lamborghini is a car and a car is a vehicle. So Lamborghini is more likely the child of car, of class car. So this is it. Now we want to know what does a Lamborghini has more than its vehicle, more than the characteristics of a car. A Lamborghini has what does a Lamborghini have, by the way? It has a steering, it has 4 tires, it has a brake light. I'm just joking. So a Lamborghini can have, yeah, actually, what does a Lamborghini has? It has its engine power. So the type of engine will be written here. Now, engine capacity, whether it's 3 liter, it's 4 liter. capacity, or just say it's Lamborghini, it's which one? String, it's model name, and then we have std string transmission, whether it's automated or manual. Now that we have made our relation with these, this kind of process is called inheritance. So if I were to make this one graphically, I would say vehicle and then let's just comment this out. Vehicle is a parent, and then there comes car. Actually, this thing, the arrow's direction is the other way. So but vehicle comes here. You point toward the class which is the parent class, so car. And in return, you're going to put an arrow to Lamborghini. It happens like this. So you make an arrow towards the parent class, the one you are inheriting from. So this is it. The relation is like this. Vehicle sends all its inherited properties towards class, then the class car, and car has its own functionalities in addition to the functionalities that has been inherited by the vehicle class. Then there is a Lamborghini class that has its own functionality in addition to the functionality inherited by the Lamborghini from the car. So in order to make you understand, I will make them public for a while, for this lecture, so that we can see, and then we will learn the polymorphism in the end of this lecture. So here it is. Now if I were to create an object of Lamborghini, okay, Lamborghini, I would say L1, that's it, object created. Oh my, how can I spell Lamborghini wrong? It's a sin. Is it okay, right? Okay, it's okay. Now I'm going to see what does, but first I would declare an object of vehicle and see what does vehicle have. Vehicle v1 dot. Now vehicle v1 has, wait, is it joking? v1 dot. So v1 has color, it has engine. The two string similar, just exactly that we created above in the class. So when you put a dot in front, we have a color, we have engine. Don't be bothered by vehicle and assignment operator. So this was it. Vehicle has engine and a color. Now we need to see what a car class has to offer. C1 and say C1 dot. So C1 has seating capacity, it has type, it has color and engine. And when we give a little bit attention, we see that vehicle and scope resolution operator. That means from vehicle it has inherited color and engine, although I did not put any engine and color variable inside the vehicle class, but still those are inside and invisible. So those are inherited. And when I create a Lamborghini object, say L1, I'm going to see what's inside. So we have model name, we have transmission, and from vehicle class we have got color and engine, and from car class we have type and seating capacity. So this is all about inheritance. You can individually give them value by dot notation, or you can have your own functions. Now if I wanted to, you know, put in my constructor, I'll just private you know that if I don't put this private keyword inside, it doesn't make a difference, because classes, individual methods and properties are private by default, but it's more likely to enhance our readability. So now I'm going to vehicle and say std string, and I'm going to call it engine, and then I'm going to have another std string for its color. Then I'm going to use an initializer list, and I'm going to have engine inside. Then I'm going to have another engine inside. Then I'm going to have a colors variable initialized, and then I'm going to have a color, and then that is going to end my constructor, right? So just to check whether it points towards the same thing, I'm going to put the cursor on engine, so it's pointing towards the same thing it highlights. So when I put engine on this one, or say color, why it's not pointing towards it? So when I say color, it's the right color. When I say engine, it's the right engine it's pointing to. So this was our vehicles constructor, values assigned. Now we want to create our constructor for public and then in this one we want to create the constructor for car, and then the car has an integer, and then it has an std type. But we're forgetting something, don't we? Aren't we? We are forgetting to provide the variable, the literals that we want to assign to the vehicle. If we are trying to create an object, we are totally ignoring the properties inside vehicle class. How are we going to initialize that? So for that, we need to have our parameters set for that job as well. Std string engine, then std string color, and now what we need to do is to call the constructor of vehicle class to assign the values of to these. So here in initializer list, I'm going to call the constructor. I'm going to send in the parameters of engine, right? This one, engine and color. So engine and then color. Is it okay? So that engine constructor is called. You see, it highlights the way vehicles constructor. It's called. And now similar to last time, same as the last time, we are going to initialize our seating capacity with seating capacity, and our type with type. Okay, you could have named these parameters anything else, but I've named them as like. Now I need to create a constructor for Lamborghini as well. Public, then I have the constructor for Lamborghini, Similarly, we are going to include these variables as well as like we did last time, so that we can not just initialize the properties present in Lamborghini class, but also pass those variables inside the vehicle class. I'll just put in this assign some outputs so that you know that how the constructors were called each time. But now I want to have std string, and in string I'm going to pass model std string transmission. Oh my god, transmission, is that correct? Transmission. So model transmission are done, but before that we need to have variables. I'm just going to copy them. Oh, what was that? Copy and paste, and then I believe there is string type here, and there is a std here. So std string engine, std string color, std int seating capacity, std string type, std string model, std string transmission, and expected something like. Now we need to have our initializer. We need to have our initializer list. So now you see, as I start to define my constructors, parameterized constructors, so compiler itself deletes that default constructor which was without parameters inside it, was deleted. So as long as we don't provide our own constructor, compiler is going to provide one default constructor. But as I start to declare my own constructors, it's giving errors because there is no default constructor now. So now whenever we want to create the values, we need to have our own, we need to call the constructor the right way we designed it to be called. Now we need to have cars constructor. So the first things first, we need to have the constructor called for the car, because car, if we call the constructor for call in car constructor, vehicles constructor will automatically be called. Understand? So I'm just going to go and call the car constructor. Where did I call it? So car constructor called, and this I'm going to send few things, that is engine. So the first thing goes here is engine, then is color, engine, what? So car has engine, it has a color, then it has seating capacity, then it has a type. Okay, so this was the constructor for car. These two values will automatically go to the vehicle, as if you can see here, engine and the color. So these two values will map on these two, and these two will accordingly go on with engine and color. That's how it works. And then we are going to individually initialize an initializer list, model name and transmission. Model name is going to be model, and then transmission. The reason I'm using model instead of model name, as I've used the parameter exactly the same name as they are in property, as property name, just to show you that we can change these parameter names. Okay, so transmission. I know this video can be a bit confusing to you. It was confusing to me when I was learning, so no shame in that. You can go ahead and go through this video again and again. What's the problem now? It's transmission. Okay, so wrong spellings. Transmission. Transmission. This is the same transmission. Okay, so that's how we do it. Now we need to have that one we can handle with. Now we need to make the print functions individually. So now we need to print vehicle, and in this one the return type should be void. I'm going to do std. Now the things are done. It's only the matter of output to show you that what is the output. Engine, then there is color, std endl. Engine is, and then on the next line I want to color is. Okay, so this is it. The print function for vehicle is done. Then we need to have our print function defined for car. Print car. Then there is std cout. Then there is first we want to call our print vehicle function, because remember, print vehicle function is already there inside this one, this car, because that is now, as it's defined up here, it has been inherited by print car, so you can have liberty to call it. So print car function is a print car, print vehicle function is here, so go ahead and call it, and now you can have your own things called. So it has seating capacity is seating capacity variable, which is an integer. Then we have our escape line, should be inside the string, escape line, seating capacity, and then the other thing is engine type is, I don't know much about this, but I've been hearing things about engine and engine type being different things, and then there is a type. And then we are going to use std endl, then com. So print vehicle will be called, that means if you just call print car, this thing will be printed by this one, and then seating capacity will be printed automatically. But what we want to do with the Lamborghini, we want to just call print car, that is print wide, print Lambo, print M, then print car. If you just call print car, which has print vehicle inside, will be automatically called. So these two things will automatically now be printed. You need to take care of the properties that are inside your Lamborghini class, the class you're currently working on. So std cout model is modeling. Then there is transmission with transmission type, type of transmission std endl. So we're done. This is it. Now let's take our classes for a row. So first we want to create a vehicle, or you can just create a Lamborghini class directly. Lamborghini class, and in Lamborghini class you need to have your own constructor, and in constructor you're going to write, you can just take here, engine. So first is the string, so engine is going to be 6.4 liter, okay, 6.4 liter, okay, so this is your engine, generic engine. Then there is a color is going to be yellow. Then there is a seating capacity which is integer, so that should be 2. So we have an engine type now, which is a string, which is going to be V8. Then we have our model name, which is a string. I'm going to call it Aventador, the best ever car ever made on this earth, Aventador. Then we have a string transmission. It's going to be automatic. So this is done. Transmission is done. So what's the last thing I'm missing? I have engine, I have color, I have seating capacity, I have type. Okay, seating capacity, engine type, then it has model, then it has transmission. What am I missing? I'm missing a statement terminator, and if I just do this, I'm going to say l.print Lamborghini and see what happens.
Build started.
Okay, still building. Here, I'll just... So engine is 6.4 liter, color is yellow, seating capacity is 2, engine type is V8. So these two lines are being printed by the car. Remember, engine and color was the job of print vehicle function, which we called in here, and it was inherited by the car. So if you just want to use print vehicle function, you can just say l.print vehicle function. You can call that function specifically as well, because that is inherited in Lamborghini class. So whatever is the job of print vehicle function, you can... Print vehicle function is private, and because inheritance is done in a private way. So we have another problem now. For now, to solve this problem, just write public whenever you're doing inheritance. What it actually does, it hides the it unavailables the, what you say, it hides all the things that are, you know, coming down. So if you're trying to use the inherited features of the parent class and the class above the parent class, it says no to that, okay, or above class, because we have been doing private, so the inheritance by default is private. When you want to use those functions as well, you need to write public here. So Lamborghini public, vehicle class doesn't inherit from anything. Now this error will be solved. And you see, we accessed that print vehicle function just as it is. Or if you just say remove the public from here, just to show you once again, and see, I cannot call print vehicle function. Now just print car function. Let's see whether we call that one, whether we can call this one. No, we cannot call this one as well, because this is also a private member. So what you need to do is you need to declare them as a public inheritance, and then everything should be good. You will be able to use all those functions that are inherited by default. But you still can use the things inside the class, the immediate upper class, not the functions above that. If you're doing the private inheritance, those features, like I'm calling print car here in Lamborghini, I cannot call print vehicle here, because that is one step above above the inheritance. Okay, so because this is Lamborghini class is inheriting from vehicle and the car as well, so it can call print car because it is directly above and is a direct parent class. Let me just put it this way. You can use, whenever you're doing private inheritance, you can use your parent class feature, but you cannot use your grandparent class methods. Okay, you can use the methods of your parent class, but you cannot use the method of your grandparents and great grandparents class. Okay, so this was it for today's video. Till then, keep smiling, stay smiling, spread smiles and seek smiles. Allah Hafiz.